everyone. The God in me greets the God in you. God bless you. I am Enrico V. Manguerra.
I am Arjon Andrin.
I'm Kanna Arellano.
And we are Group Volt³. And we are from kit number 2, grade 12 Genesis.
Here is a table of contents for this video and their respective timelines.
In our activities, we learn how to use the serial monitor to display and read the data from the Arduino. Overall, each activity helps us understand debugging, wiring, and how sensor and outputs work together. We can apply what we learn to create automation projects like smart lighting, heat detectors, and motor control system. In activity 1, we printed text and learned how to match the correct baud rate. In activity 2, we displayed temperature reading and fixed wiring issue to make the output accurate. In activity 3, we checked if the button was pressed and solved the bounce problem in our code. Activity 4, we used the serial monitor as a remote control by typing commands to control the device. In activity 5, we log light sensor reading and use averaging to make the data more stable.
The ultrasonic sensor is a key component in robotics for detecting object proximity without physical contact. It's a great hands-on way to learn about how sensors interact with microcontrollers and how real-time decisions are made in embedded systems. This project uses an HCSR04 ultrasonic sensor with an Arduino UNO. To measure the distance between the sensor and an object, the sensor sends out sound waves and listens for the echo. The Arduino calculates the time it takes for the echo to return and converts it into a distance, which is then displayed on the serial monitor. The problem here is incorrect wiring or unstable connections. If the pins are not properly connected to the correct digital pins, the sensor won't function as expected. This project uses an ultrasonic sensor to measure the distance to an object and displays the result on an LCD. Incorrect address or wiring issues can prevent the LCD from displaying anything. If the screen stays blank, we double-check the address and make sure SDA and SCL are connected to the correct Arduino pins. This activity introduced distance sensing using the HCSR04 ultrasonic sensor and an Arduino UNO. The goal is to build a simple system that detects nearby objects and responds by turning on an LED when something comes within 10 centimeters. Parking assistance system. This project simulates a real-world parking sensor, like the one used in cars to detect nearby obstacles. We will use an ultrasonic sensor to measure the distance between a toy car and an object, and then give feedback using LEDs and a buzzer. This activity uses an IR proximity sensor to distinguish between black and white surfaces based on how they reflect infrared light. When placed close to a surface, the sensor detects the amount of reflected IR light and sends a digital signal to the Arduino. White surfaces reflect more IR light, triggering a high signal, while black surfaces absorb more light, resulting in a low signal. A common issue during this activity is inconsistent sensor readings, especially if the surface is too far from the sensor or the ambient lighting with IR detection. This activity introduces a simple proximity-based alarm system, a buzzer and optionally an LED when an object such as a hand or person comes close to the sensor. It detects the change in infrared reflectivity and sends a signal to the Arduino. This setup demonstrates how sensors can be used for security, automation, and interactive systems. A common issue during this activity is false triggering or inconsistent detection. This often happens when the sensor is exposed to strong ambient light, reflective surface, or placed too far from the object. This activity demonstrates how a sensor can be used to count the number of objects passing in front of it. The total count is displayed on a LCD screen, making it easy to monitor traffic or movement in a given area. A common problem in this activity is multiple or miscounts, which can occur if the sensor is too sensitive or not sensitive enough.
In activity 1, we created a button control DC motor using the MOSFET. The motor turns on and off with a button press, and at first the motor didn't spin because of wiring issues, but we solved it by checking the connection and using an internal power source. This activity is useful for simple control system like fans or toy cars. In activity 2, we built a DC motor speed control using a potentiometer and MOSFET. By adjusting the potentiometer, we control the motor speed. We face challenges with uneven speed response, with which we fix using PWM through analog write. This activity is useful for robotics and automation where precise motor control is needed.
This activity is similar to the previous activities, but we will be using the DC motor with the H-bridge instead of the MOSFET. This is useful to change the motor's direction, which can be used in creating electric vehicles and lifts. In the first activity, we connected the Arduino UNO, 9-volt battery, DC motor, and H-bridge together to turn the motor on and off in one direction for 1 second each. We had the most trouble in connecting all the wires together since there are lots of connections in this activity. In the second activity, we used the same setup but connected the pin 9 of the H-bridge to pin 9 of the Arduino, which is a PWM pin, to control the speed. The motor accelerates and decelerates when spinning. It was not too difficult except for needing to be careful to change only the wire of the set pin. In the third activity, we connected pins 10 and 15 of the H-bridge to Arduino 12 and 13 pins, respectively, to control the direction of the motor. The motor spins forwards for 2 seconds, stops for 1 second, spins backwards for 2 more seconds before stopping for another second and repeat. Like the second activity, we needed to be careful in changing only specific connections in the breadboard and the Arduino. In the fourth activity, we added 2 push buttons in the previous connection to control the direction that the DC motor spins towards. One push button is for forward spin and the other is for backward spin. Finding a proper space to connect the buttons properly was the challenge here. In the fifth and last activity, we added a potentiometer to the fourth activity to be able to control both the direction of the motor using the 2 push buttons and the speed of the motor using the potentiometer. Rotating the potentiometer while testing was a difficult challenge because it was put on a cramped space on the breadboard. In conclusion, we, Group Volt³, have learned how to integrate and connect different sensors, motors, and other output devices to perform specific tasks. This hands-on experience helped us to write and debug Arduino code to read and display results from sensors in real time. The journey has reshaped our view in technology and engineering. Robotics is not just about machines, but also about problem solving, creativity, and teamwork towards creating technology that can make our life better and inspiring innovation. Furthermore, we look forward on learning about other modules and components such as the camera module, water and soil moisture sensors, as well as RFID and keypad modules. Each new part brings new possibilities in creating innovative projects that can improve our lives. Again, I am Enrico B. Manguerra, the leader of Group Volt³. Thank you for watching.